But with the introduction of physically based rendering, or PBR, we're now able to base these calculations on actual physical principles. PBR is essentially using what we know about the physical behavior of light to render natural looking materials. In Unity, we can use the standard shader to do exactly this. The standard shader allows you to take advantage of our knowledge of how light interacts with materials in the real world to get really realistic results. And because it's based on real-world physics calculations, the standard shader will also keep the look of materials consistent under different lighting conditions. So let's take a look at how light behaves in the real world. When light hits an object, some portion of the light will be reflected off the surface. In computer graphics, we often talk about specularity or specular reflection, which is the amount of reflectivity a surface has. When light gets reflected, it leaves the surface in the opposing angle of the surface normal. But with the exception of a perfect mirror, all the light is not reflected directly off of the surface. A portion of it will enter the material where it can either be absorbed or diffused. Diffuse reflection refers to light being tossed around inside an object until eventually leaving the surface in different directions. This is what makes the material itself visible to our eyes. Now, staying on the subject of diffuse reflection versus specular reflection, we can see that the more specular a material is, the less diffuse it should be. If we think about this logically, it makes sense. When looking at a mirror, it takes on the colors of the environment, but the color of the mirror itself isn't really visible. If we look at a brick, we don't see much of the environment, instead we see the brown-orange color of the material itself. This is due because the physical properties of metals are very different from just about any other material. Firstly, they tend to be much more reflective than non-metals. This is something, the example of this is copper or gold. And speaking of gold, another golden term to know is Fresnel. Fresnel refers to the fact that the amount of light that gets reflected varies at different angles. In the real world, at the very edge of an object, the amount of light reflected will be 100%. The amount reflected at the center of the object is what we refer to as the base reflectivity. With a PBR workflow, Fresnel is applied automatically when rendering based on the reflectivity you input on the material. The Fresnel effect becomes less apparent as the surface becomes less smooth, but it applies to every single thing around us, which in turn speaks to the fact that even the roughest materials have a reflection. Now, another thing that applies to all objects is that all objects actually have small imperfections, cracks and bumps in their surface. They might be too small to see, but they're definitely there. This is referred to as the microsurface, and it can play a big role in how light is reflected and later perceived. The more uneven and rough the microsurface gets, the more diverged and blurry the reflected light looks. The roughness of a material is often referred to as gloss, or in the case of Unity as smoothness. So that's a quick overview of how these things work in the real world. But how about in Unity? Well, as mentioned earlier, Unity has a built-in standard shader that automatically sets up a lot of this for you. The standard shader gathers all of the calculations needed to create realistic looking materials using PBR. A good thing about the standard shader is that even though it has a bunch of features, it discards all unused properties when it's built, which really helps optimize it. The standard shader is also very versatile because you can choose between multiple workflows. Each workflow represents a different way of thinking about PBR, but all of them can achieve the same realistic results. The standard shader's default workflow is metallic. This has nothing to do with the material necessarily having to look like metal. Instead, it means that this approach to physically based rendering is based on defining how metallic or non-metallic the surface of the material should be. The specular workflow is also really common. This lets you have direct control over the brightness and tint of specular highlights. In a metallic workflow, this gets calculated automatically. So for the sake of simplicity, let's focus on the metallic workflow and go through the shader properties to see how they affect the material. Some of the properties we can adjust are color, metallicness, and smoothness. But for most assets, we don't want these values to be uniform across the entire model. Instead, we use something called texture maps to change them for different points on the surface. So what is a texture map? A texture map is basically an image. For each pixel on the image, we can specify a color. Each color consists of a red, green, and blue value. These are called channels. However, each pixel actually has a fourth channel, the alpha channel. Normally, this is used to define transparency, but as you'll see further down the line, we